Hello guys, this is Srijesh and today we are going to start with class 11th chemistry, some basic concepts of chemistry. So to start off, we need to understand what chemistry really is. Chemistry is the branch of science which deals with the study of matter. So matter is made up of atoms and molecules. So we can say that chemistry is also the branch of science which deals with atoms and molecules, because matter is made up of atoms and molecules itself. So whatever is written in the NCERT till topic 1.4 is not that important for the examinations. So I'm going to skip directly to topic 1.4, which is uncertainty in measurements. Uncertainty in measurements is a very important topic, and what it means is that, let's say you have a scale or a ruler. The edge of a ruler looks somewhat like this, right? It looks somewhat like this, and there are markings made over here, right? So what happens many times is that if we want, let's just say that this is 5, this is 1 2 3 4, right? So let's just say that we want to mark 1. Sometimes what happens is that we mistakenly mark 0.9 or 1.1 or 1.2 or 0.8. That happens mistakenly. So what it actually means is that the true value that we are trying to measure, it does not remain same. It does not remain true. We don't actually know whether the value that we are measuring is correct or not. And this is basic human error. It happens many times. So it's not something that happens purposefully. So this happens in many cases, not just the case of measuring something with the ruler, but also in the case of weights and many other things, that anything we measure will have uncertainty when we measure it. So scientists have devised many methods to reduce the amount of uncertainty in measurements, and we are going to learn 3 ways in the NCERT textbook. The three ways which scientists have found out to reduce the number of uncertainty in measurements will be scientific notation, then comes the significant figures, and the dimensional analysis. These are the 3 ways. There are many ways of reducing uncertainty measurements, but these are the 3 ways that are given in the NCERT textbook. And these 3 ways are very important for us to know and understand. So let us start with scientific notation. So scientific notation is just another way of writing a number. It's a simple method. So this is used in chemistry because in chemistry we deal with very huge numbers. You might be familiar with the number of Avogadro, or known as Avogadro's number, which is represented as 6.022 into 10 raised to 23, right? This is a number, right? And this particular number is represented in scientific notation. This number is actually equal to 6022 this. So 6.022 into 10 raised to 23 is actually equal to this huge number. So obviously this is easier to write than this. In examinations we need to be quick, and in scientific calculations also we need to be quick. So scientific notation is used. So basically, scientific notation is just an easier way of representing very large or very small numbers, but we can also use it to represent any number. I will give you an example. So this number 175,000 can be written as 1.75 into 10 raised to 5. So we need to know what are the rules of writing scientific notation. So the first rule of writing scientific notation is decimal point is moved to the left of the number until and unless there is only one non-zero number remaining on the left. So what does that mean? Let us take the same example. In this example, we can see that there are 1, 2, 3, 4, 5, 6 digits, and the decimal point is present over here after the sixth digit. We are moving the decimal point towards the left. 1 place, 2 places, 3 places, 4 places, 5 places. Now, after I reached to the 5th place, I understood that there is only one non-zero number left on the left side of the decimal point. I stop there and then I write, which is equal to 1.75 multiplied by 10 raised to the number of times I moved the decimal point to the left, which is 5. That's how we get it. So basically, we remove all the zeros that are coming at the end of the number to the right hand side of the decimal point. Okay, maybe you didn't understand. So we could have also written it as 1.75 000 times 10 raised to 5. It's the same thing, but there is no point of writing this. So basically, we do not write the zeros coming at the end, only coming at the end to the right side of the decimal. But let's just say that in any given example, there are zeros in between two non-zero digits to the right side of the decimal. Then we do write the 0 over there only. We do not remove it. Okay, on to the second rule. So the general representation of a number in the scientific notation should be n into 10 raised to small letter n. In this general representation, we can say that this notation means where, and upside down a means where. So the small letter n is an exponent which may be positive or negative. And the large letter n is any number between, now I'm stressing on the word between, 1 and 10. So n can take the value, n can take any value that is greater than 1 but lesser than 10. So the value may be 1.00000, infinite zeros and 1, or 9.999999, infinitely and 9. It can be anything, but it should be more than 1 but less than 10. Now let's move on to the algebra of scientific notation. Now I mean addition, subtraction, multiplication and division by algebra. So let's start off with the addition and subtraction of numbers in scientific notation. So the basic rule for us to add or subtract scientific notation for numbers in scientific notation is that the power of 10, i.e. the small letter n in the general formula, must be the same in both the numbers. And the numbers, which is the exponent of 10, should be the same. So let's try to understand this using an example. So let's take the number 3.425 times 10 raised to 4 plus 3.425 times 10 raised to 3. So what we need to do here is that we can see the power of 10 in both the numbers is different. In one number it is 4 and in the other number it is 3. So what we need to do here is we need to make this number 4 or make this number 3. And to do that, we can do that in two ways. So we can either say this is equal to 34.25 into 10 raised to 3 plus 3.425 times 10 raised to 3, or we can also do this as 3.425 times 10 raised to 4 plus 0.3425 times 10 raised to 4. Let's take one example, which is this one. So let's write it down. So this must be equal to 3.425 plus 0.3425 into 10 raised to 4. So if we make the power of the 10 same in both the numbers, then we can take the same power and multiply it with the final answer. So it's basically like you're adding or subtracting both the decimal numbers and then just keeping the 10 with the power as the same. So this should come as 3.7675 times 10 raised to 4, and that's how you add numbers in scientific notation. Now you do the same with subtraction. If there is a subtraction, you can put a subtraction over here. So let's just say this is add or subtract, then this will also become add or subtract, and this will become 3.0825 times 10 raised to 4. If we are subtracting these two numbers, then the answer will become this, and if we are adding the two numbers, the answer will become this. Now let's move on to multiplication and division of numbers in scientific notation. So let's start off with multiplication and division of numbers in scientific notation. This is actually very simple. What we need to do is understand it with the help of an example. So let's take the same two numbers that we took before, which would be 3.425 times 10 raised to 5 multiplied by 3.425 times 10 raised to 8. Now what we are going to do is we are going to multiply both the integers. We are going to multiply both the integers as though we were going to do it normally. So it's 3.425 multiplied by 3.425, and then we multiply 10 raised to 5 plus 8. Now notice the exponents, the power of both the tens, which is 5 and 8, are getting added instead of multiplied. That's how powers of 10 are multiplied. So we should probably get an answer of 11.73 times 10 raised to 13. Now this is the case of multiplication. So the rule which I said about the exponents or the powers of 10 getting added can be generally written as 10 raised to x plus 10 raised to y, or 10 raised to x multiplied by 10 raised to y should give 10 raised to x plus y. That's the basic rule. And in division, the powers of 10 get added in this way. 10 raised to x divided by 10 raised to 5 is equal to 10 raised to x minus y. That's how the powers of x, the powers of 10 get added or powers of any same number get added. Both the numbers should be same. It is not necessary to be 10, but whenever same numbers having different integers of different exponential values or powers are divided, this is what happens, and whenever they are multiplied, this is what happens. And let's take the same example. If we are dividing, then 3.425 times 10 raised to 5 divided by 3.425 times 10 raised to 8, we get 3.425 divided by 3.425. So you can see how the normal integers are divided. They are divided normally, like as you would divide normal integers, and then multiplied by 10 raised to 5 minus 8. So this should give you 1 into 10 raised to negative 3. That's the value. Hope you guys understood. Now I'm going to give you some practice problems so that you can try it out by yourself. So these are some problems that I recommend you to try it out. I'll give you 5 seconds to pause the video and try it out. Okay, so these are the solutions of the problems. I hope you guys enjoyed this video. Our next video will be about significant figures. Thank you guys so much. I hope you